Okay, I've redone this example a little bit just so it's a little bit clearer. Let's suppose that you are in a castle that has 100 rooms, including a vault and a dungeon. You start in the dungeon where there are 5 coins. The object of the game is to get those 5 coins into the vault in the shortest amount of time. You can only pick up 1 coin at a time, and once you pick up a coin, you can't put it down again until you're at the vault. Picking up a coin takes 1 time step. Moving between 2 adjacent rooms takes 1 time step. There are ogres running around in the castle that you may need to fight to get past. Fighting takes between 2 and 10 time steps. Okay, and our goal is to come up with an admissible heuristic for this problem. All right, and a reminder, admissible heuristic, a heuristic is just our non-negative estimate of the cost of the shortest path from a node to a goal node, right? So we have to have, it's a function that gives us a value that we can run on every single node, and it gives us this non-negative estimate. Our heuristic function is admissible if for every single node, the heuristic for that node is less than or equal to the cost of the cheapest path to the goal. So in our castle problem, our goal state is a state where there are 5 coins in the vault, right? Okay, and we want to find a way to do it as fast as possible. So here's one admissible heuristic for this problem, okay? If you already have 5 coins in the vault, well, you've achieved your goal. The heuristic's going to be 0. Otherwise, it's going to be 5 minus the number of coins in the vault. In other words, if you don't have all the coins in the vault, like if you have 4 coins in the vault, your heuristic's going to be 1. If you have 3 coins in the vault, your heuristic is going to be 2. Is this a great heuristic? No. Is it a heuristic? Absolutely. It's a non-negative estimate of the cost, and it's also an admissible heuristic because the value is less than or equal to the cost of the cheapest path to a goal. Here's another admissible heuristic, not necessarily better or worse. We're going to say that the value of the heuristic is 0 now if there are greater than or equal to 4 coins in the vault. So it's now our heuristic is not 0 when only when we have our goal state. It's also when we have 4 coins in the vault already. And otherwise, the cost is going to be the shortest time, or the value of the heuristic is going to be the shortest time it would take you to walk from the dungeon to the vault if you didn't encounter any ogres. So notice that if I already have 4 coins in the vault, I might be standing next to the vault. And so that would only take me 1 step. And so what I've done is I've said, okay, if there's 4 or 5 coins in the vault, it's 0. But if there's 3 coins in the vault, I'm just going to make my heuristic be the shortest time it would take you to walk from the dungeon to the vault if you didn't encounter any ogres. And here's one other possible heuristic. I took the shortest time it would take you to walk from the dungeon to the vault 1 time if you don't encounter any ogres. And now I'm taking 4 minus the number of coins in the vault and multiplying by this thing. So just bear with me for a second. If there's already 4 coins in the vault, your heuristic is going to be 0 because I might not have to walk all the way from the dungeon to the vault. I might already be 1 step away from the vault with one of those coins. But if I have, say, 3 coins in the vault, then I know for sure that there's at least 2 coins not in the vault. And one of those coins has to still be back in the castle because of the crazy rules that I set up for this game, where I said that you can only pick up 1 coin at a time, and once you pick up a coin, you can't put it down until you're at the vault. So I think I have made the problem complicated enough that that it works. And we could come up with others too. I mean, I was thinking, oh, maybe we should talk about not just the time it takes you to walk from the dungeon to the vault, but back and forth or something. Whatever. These are it's just supposed to be an example. Okay?